welcome to Shifting Security Left while building a cloud-native bank. My name is Kasper, and just briefly a little bit about who I am. I'm the lead platform architect at a company called Lunar, and we'll come back to what we do in a second, but you probably guessed it in the name of this talk. I'm also a Cloud Native Computing Foundation ambassador. I co-founded and now lead the Cloud Native Nordics meetup community as well. We are sort of a meetup alliance across the Nordic countries that just try to spread the word around Cloud Native. I also do the local organizing in Aarhus, the city that I live in, both around Cloud Native, but also around Go, the programming language as well. I try to occasionally speak at various meetups and conferences like this and share our experiences from Lunar, but also our experiences in general from the community. I have this blog called kubecloud.io. It's not that updated, but you can find some really interesting topics around that I wrote about Raspberry Pis and Kubernetes back in 2016. It's up there if you're interested. So what to expect from this talk? Well, hopefully I will provide you with some lessons learned in the process of shifting left from our experience and how you can sort of stay agile and secure at the same time. And before we dive into all the details and all that, let me just briefly introduce you to Lunar and what we do. So we were founded back in 2015 as Lunar Way, and we are a smartphone-only challenger bank. It was originally built on top of an existing bank, meaning we were leveraging an existing bank's banking license and all of their infrastructure and sort of APIs and stuff like that. Then back in 2019, we received our own banking license and spent some time building, so to speak, the real bank, and went live in 2020, in the beginning of 2020. And the idea and focus is to be best in class of UX and support. And yeah, we're also fully cloud-based, and we think that's the right approach to a 21st century bank. We're currently live in Denmark, Norway, and Sweden. Yeah, so that's briefly about Lunar. And, you know, banks are boring, right? Banks are old. And from a sort of a technical perspective, banks are sort of affiliated with mainframes and COBOL and stuff like that. So how do you actually build a bank in the 21st century? That was basically the task that we were sort of handed over. So a clean sheet of paper, start from scratch, figure out how to actually build a new bank in the 21st century. So how do we actually do that? One thing that we know being in technology is that change is inevitable, right? So the only constant in life is change. Change is inevitable. And we also experienced that. We started out building a monolithic application in Rails, as every startup story out there. Started figuring out that was probably not the right way to build a new bank, and tried to migrate into what we could see was sort of where everybody else was moving into microservices, and ended up sort of building a distributed monolith and forgot about some of the key principles in actually building a microservice architecture. But now I think we are sort of at a place where we are running autonomous microservices and have independent deployability and service ownership and all the things that comes with running a microservice architecture. But I don't really see this as a bad thing. It's a learning experience, and building a monolithic first is probably a good decision for many startups, because you need to prove value in the beginning. And that was the exact same case for us. And then at some point you figure out, okay, maybe this is not how we're supposed to do it, but then you have a lot more sort of insights into how your system should be decomposed, whether it's going to be a microservice architecture or just a decomposed monolithic application. That's up to you. We chose microservices and are really happy with our decision now. And again, yeah, we cannot predict when changes in the technical or domain landscape occur, just that they will, and we don't even know which changes will persist. So we just know that it's inevitable. So we need to architect our systems knowing that the technical landscape will change, because it will. And this quote is from the Building Evolutionary Architectures book, which is a really good book. I highly recommend that. But it's just saying that you need to when you sort of build your architecture, think in that change is inevitable. It will change at some point. So make it easy for you to take on new technology and add new stuff going forward. And then what else? So that was sort of the application architecture side of things. We also need to deploy these microservices some way. I was hired back in 2016, and my key task when I was hired was to sort of break down this monolithic microservice thing that they were sort of trying to build. They had monolithic deployment. They deployed, I think, 7 microservices at the same time. So we just needed to sort of rip that apart and come to a place where independent deployability was an option. And that's why we sort of started looking at cloud native. I came from a Kubernetes background with my master thesis, so Kubernetes was the obvious choice to figure out how we can actually manage these microservices. So cloud native it was a very important thing as well. And just so that we are on the same page, cloud native is not sort of the cloud. The cloud is this on-demand delivery of infrastructure, hardware, services, storage, databases, and all kinds of different services that you can get. When I say cloud native, it's more about an architecture for assembling all of these services that you find in these maybe cloud environments or wherever you sort of have those things available. There's also private cloud, hybrid cloud, multi-cloud, a lot of different ways to do cloud, but cloud native is more about just assembling what you need and how you can so that you can optimize for your environment. And it's not about the servers anymore. Back in the day, we had these pet servers, and now it's more about the services that are actually running there. That's important, and we just name services with numbers and hashes and stuff like that, so that it's more like cattle, if you're familiar with that term. And this is also what Google sort of experienced in their transformation into containerization, because it's pretty much the same thing that was sort of stated on the previous slide, but this is from the research paper done by Google. And containerization transforms the data center from being this machine-oriented to being application-oriented, and that's very sort of the heart and focus of this, is that we can shift the focus to the application rather than on the actual server itself. Which is really nice. And also Cloud Native Computing Foundation has a definition of what Cloud Native is, right? It's about containers, microservices, immutable infrastructure, and declarative APIs. Some of the things that are in this approach. And what it enables is loosely coupled systems that are resilient. That's also why we wanted to go down this path. We sort of want to break down all these dependencies between services and make them independent deployable. But we also need to manage all of those services. So scaling a microservice or architecture, how do you actually manage all of those microservices? And then when you have stuff running in production, how do you actually observe them? And the whole idea of all of this is basically to be able to make high impact changes frequently and predictably with minimal toil. And that was the exact same thing for us, right? We needed to be able to move fast, try out new things, deploy a new service, test if it was working, and if not, just throw it away again. So yeah, and then the CNCF, the Cloud Native Computing Foundation, are sort of helping the adoption of this pattern by sustaining the ecosystem of open source and vendor-neutral projects. So yeah. And yeah, Lunar is a proud end-user supporter of the Cloud Native Computing Foundation. I also saw our logo on the Cheryl's slide in the previous presentation. This is just a recommendation as well to join the end-user community. It's a really cool community, and there's a lot of like-minded people that are in the same situation as you that tries to figure out how to actually adopt Cloud Native. So this is just a recommendation of joining as well and sharing your experiences. But then what about security when we move into this world? I think that security needs to be rethinked as well. We cannot use the old models to some extent anymore. We need to figure out how to actually approach this again in a new way. Because we have this conundrum, how can we be agile and secure at the same time? This is two sort of opposites that we are trying to figure out how to manage. And shifting left, let's talk a little bit about what that actually means before we sort of dive into how we actually sort of approach this at Lunar. You probably all know the waterfall model. Shifting left, where we basically means that we move things that we did typically late before. We move that up early and do that continually and just having this feedback loop running, whether that's testing, security, frequent deployment. It's all about what DevOps is, right? It's about having this feedback loop. So we want to do that for security as well. And now we have this microservice architecture where we have multiple teams, and we try to make them responsible for the software they build. That's also how Amazon did it back in the day with you build it, you run it. And we try to do the same thing. So one thing that becomes really important when you do a microservice architecture and try to shift left is that service ownership and have clear boundaries and definitions of what service ownership actually means and what it means to own a specific service. We've been looking a lot at single team owned service architecture, Stosa from the Architecting for Scale book. I just highlighted a few of the points in the book. And what it's all about is that each and every service in your application must be assigned to a development team. And it needs to be very visible who actually owns that service. And teams are ultimately responsible for all aspects of managing a service, whether that's being architecture, design, to development, to testing, to deployment, to monitoring, and also incident resolution in the end, right? We are not completely there yet in terms of incident resolution. We have a central on-call team, but we are sort of slowly moving in that direction as well. It's also about how big of an organization you have in order to actually be able to do that. And services have strong boundaries between them, including well-documented APIs, right? So what it all comes down to is that in a Stosa organization, the team that owns the service is ultimately 100% responsible for all aspects of that service. Then we have the platform team, which I'm part of, that tries to provide a lot of tooling and make it easy for all the developers to actually take on this responsibility. And that's where we come into how we do stuff at Lunar, and how we empower our developers to actually be able to take on this responsibility. And it starts with onboarding. We provide, as a platform team, common tooling, access to systems, and all that is provided by our sort of central platform team. And one of the key things here is that we want to build in security by default, and we want to make it easy to do the right thing. And we have some tooling. This is an example. We have a project called LWZSH. This is just some terminal stuff that you sort of get as a developer. We use the terminal a lot. And we provide things like getting access to a Kubernetes environment or an AWS account or stuff like that is provided through our central tooling. Then you also get some nifty aliases. You don't want to spend your time writing kube control all the time, so just get pods. And also common tooling that is needed in our organization. These two are some examples that I'll come back to later, shuttle and hem control. But it also goes into service development, security by default, make it easy to do the right thing again when you develop a new service. And this is where our build, our project, it's an open source project that we built called Shuttle, comes into the picture, because with Shuttle, we try to provide sort of an abstraction across a service repository. So on one side here, you have the service repository where you have all your source code. You have also a file called shuttle.yaml. In this file, it points to another repository called the plan repository. And in the plan repository, we have a lot of central managed tooling like Docker files, Kubernetes manifests, pipeline definitions, scripting, all stuff that is needed to be able to act as a developer at Lunar and make it easy for you to do whatever you need to do in terms of implementing your features. And And if we take a look at the shuttle.yaml file, that's probably the next slide. But shuttle can then, to some extent, be viewed as a distributed makefile to some sense. It's an easy way for us to provide a central sort of managed tooling to our developers. And instead of make, build, make, test, whatever you sort of implement in your makefile, you can say shuttle run build to build a Docker container that then is sort of built from a central stored template. Also run the test commands on your service repository. You can generate Kubernetes config, and you can run security scanning as well. So there's a lot of different toolings, and there's much more than this available in these plans. And the YAML file, shuttle.yaml file, looks something like this. We point to this plan repository at the top. And as you can see here, this is a Go plan. We have plans for the different languages that we use because we have some different tooling available. We are also now in the process of figuring out how to actually sort of distribute and manage these plans and make them easier to manage than just having sort of replicas across some of the plans. But what it also provides is a clear service name and a clear service ownership. So squad NASA, in this case, that's my squad. This sort of variable is being used across Kubernetes manifests so that we can say, we can figure out who actually owns the service in Kubernetes. You can get some really nice shorthands for getting a database in our systems and getting some ingress into your service. And also you can configure, of course, how your environment is going to look like when your service is being deployed into our different environments, dev, staging, prod, as example here. And the benefits that this provides us is that we can build security in because we control this from a central hand. And I'll come back to some of the details that we do a little bit later. But it also gives us, or it also sort of removes the need for developers to actually care about Docker files and Kubernetes resources, because that's sort of our domain, so to speak. But it does also, if you really need it to do something specific as a developer, you are able to actually opt out and do the stuff, create your own Docker file, create your own manifests, if you need to add additional resources, etc. But it will still be run through our central pipeline that will sort of handle all the checks and policies that we've set up as well. It also gives a really nice way to share tooling across different services. So just an example of a team that needed some cron jobs in Kubernetes. They actually created that themselves and created a PR for our plans. And now it's available to all other squads and teams in our organization, and they can just use it as they want. So that's pretty awesome. And then the last thing is that we can verify stages in our pipeline locally, meaning that we run shuttle run in our pipelines as well. So we can do the same thing locally as we do on our Jenkins in our case. And that's pretty nice as well. So build security in and being secure by default, what does that actually mean? So some of the things that we try to provide our developers is that we need to provide same defaults for Docker containers, and there's a lot of same defaults, but this is just to highlight a few of them. Don't run root in your Docker containers, right? That's given now. We did that back in 2016 probably, and we shouldn't do that anymore. But also something like using minimal OSs. So in our case, we are very Go shop, so we can very easily just create a Docker image from scratch and just copy over a binary, and that's pretty much what's in the container image, which is also really nice. It's the footprint is really small, and also the surface of attack is really small. But also same defaults for Kubernetes manifests, specify the runner's user to be the user that you defined in your Docker file, provide service accounts for each service, and don't sort of mount the default Kubernetes API token, and also something like pod disruption budgets for availability, because that allows us as a platform team to be able to roll a cluster more safely when we have these pod disruption budgets in place for specific services. And then vulnerability scanning. Dependencies, so we, as mentioned, use Go, so Go mod, dependency scanning of all the dependencies being used there, but also package.json and whatever else we have running. It's really nice to get that. container image, the actual sort of output of the build process needs to be scanned as well. If we, for example, use another OS than just a scratch image, we need to be able to scan that as well and figure that out. We use Snyk for that. There's plenty of tools out there, open source as well, that you can take down and use to get to a point here where you can get some nice insights into your vulnerabilities. But also Kubernetes manifest validation is something that we run in the pipeline. We use kubelt for YAML validation, but also something like conf test to actually enforce some policies around how you should deploy how your services should be set up to enforce run as user, for example. We also have Steve Wade's deprecate project running. It's a project that sort of alerts you on deprecation warnings from the Kubernetes resources that you use. That's really nice. It's built on top of Contest as well. So it's just, there's some awesome tooling out there to actually get some validation and security into your pipeline as well, and stop before going into production. So empower our developers to make the right decisions when they have this ownership of all of their services. And shifting application security left means that we need to provide actionable alerts and remediation advice for our developers, because it can be really hard to just get a CVE number and figuring out what is actually, what is this? Is this something that's relevant to me? So providing some really actionable alerts and insights into sort of the severity of this is really key. But also try to be a bit smarter in terms of automating a lot of stuff, having a continuous focus, and then of course integrate it with your day-to-day monitoring solutions. An example of that is that we at Lunar built this exporter for Snyk. Again, we use Snyk for a lot of security scanning and stuff like that. And we wanted the metrics that in Snyk to be available as Prometheus metrics and be able to display them in Grafana as we use for our dashboarding solution. So that's an open source project. If you use Snyk, you can take down the Snyk exporter and run it. It's really nice to have that. And just some examples on those 4 points. Actionable insights. I like the sort of the UI and sort of the feel that we get from Snyk. That's why we chose them back in the day. They're very, very developer focused and provides a lot of actionable insights and alerts. So this is an example of where there's a remediation, and it just says that your dependencies is out of date. You should update to this and this version. It's fixed in 4.17.21. So if you upgrade to that, then you're sort of good to go, right? But even better, if you could get that as an automatic PR created on your repository, that's even better, because then you as a developer don't need to make the change yourself. Then it just comes automatically. It runs through all the different checks that you have running, and you can just merge the PR if everything looks good and it's green. So that's also a really nice feature. I think you can get the same thing, pretty much the same thing with Dependabot on GitHub and probably other tools as well. It's more just having this automatic PRs being created for you is a really nice way to help developers in sort of owning that responsibility. And then just having a continuous focus on TVEs and maybe try to make this, there's been a lot of gamification going on in different apps and stuff like that. But also here, we have this weekly updates. It's a pretty manual process, but it works really well just to have our different teams sort of put on a list, comparing each team against each other and sort of the difference from last week. It's really nice to see sort of what that actually provides as an organization, and how our developers then sort of see this as more important, because they don't want to be that team that's having all the high vulnerabilities in this case. And we also provide it on every build. So we have our Jenkins setup. It reports continually as the build is going on. And as you can see here, there's a Snyk results again shows up. So this goes directly to the developer that are sort of building and pushing this. So providing the data anywhere is possible. It's also a way to sort of have this focus and empower them to do the right things. And then the last thing, the Snyk exporter. We have these dashboards running on our TVs at the office. And as you can see here, we have other metrics from Prometheus that are interesting to us. So having the high vulnerabilities in there from Snyk again, using the Snyk exporter is really important and awesome. So let me talk a little bit about the other things that we were sort of challenged with when we in this transition from being a fintech to actually becoming a bank. We had some requirements in terms of auditability. Audit logs is very important. Limiting access to production environments was also a thing. And also when you are a financial institution and you need to be available for your customers and users to actually be able to use their card and see their balance and all that. So availability is also a key thing here. So we chose to go down the road of GitOps, and I'm really happy to see that Cheryl also had this on her list, on her predictions for the future. I think GitOps is really taking off, and it's really a strong and really helpful approach, especially for financial services institutions that has these requirements of especially audit. And just to give you just so we're on the same page, and this is the quote from Alexis Richardson, CEO at WeWorks. So it's about comparing the running state of our system with the desired state, and we do that continually. And whenever these get out of sync, we force the running state to converge into the desired state. So this is also what's called reconciliation, right? Where you specify a desired state. And in terms of Kubernetes, that could be replicas 5 or something like that. And then we have a controller in the controller manager of Kubernetes that manages and watches the current state. And if that differs for some reason, a node is dying or something like that, a new pod will be spun up somewhere else in the cluster. So that's, again, 5 replicas running. So that's just an example of how Kubernetes is doing this. And GitOps is more about applying this to sort of the entire cluster rather than just the specific application. So in this example, or in this case, we now have the Git repository as a source of truth. And then we have a controller, an operator running inside each environment, sort of converging and sort of applying the desired state into the cluster continually. And so if you make a change in Kubernetes, it will be rolled back by the operator to the source of truth defined declaratively in the Git repo. And our solution looks like this, and I know this is probably a big picture, but let's just go briefly through it. So a developer pushes some code to a service repository in our case. We kick off some continuous integration using running shuttle commands and all that, as we talked about earlier. And in the end, what comes out of that is basically an upload to an S3 bucket in our case. We call this artifacts, and it's basically just Kubernetes YAML that's sort of committed into that bucket. This tricks or sort of notifies the release manager, which is a project that I'm gonna talk a little bit more in a second, but it's a project that we built. It triggers the release manager to check for policies, and a policy could be that as a developer, I want my master branch to always be automatically deployed into production. Let's just say that. And then the release manager will take some Kubernetes YAML from the artifact storage and commit it into the production releases directory, into the config repository. And then Flux, in our case, which is our GitOps operator, will see this change and apply the configuration in the cluster. And the last step here is that we have a small tool called a release daemon that we also built as part of the release manager project. And that daemon just notifies back to the release manager, this application is now 3 out of 3, or it failed, or whatever it might be. And then the release manager can then notify the developer saying that, hey, your deployment is now running 3 out of 3, everything's good. Or here's the logs if it failed in a crash loop backoff or something like that. So we see the release manager as this continuous delivery tooling. It provides an easy way for our developers to interact with our config repository, this GitOps repository. And before you were sort of wondering about the name, Ham, the Astro chimp, was the first chimpanzee in space. And as you probably seen by now, we are sort of have this lunar theme, space theme. So Ham was a really, it just became the name of our tool. And it's, yeah, so that's why it's called ham control, not the sort of the meat ham. But what you can do is, from a developer perspective, you can say hand control release my branch being hotfix to this environment. That's pretty neat, and it sort of removes the need for our developers to actually go into Kubernetes and have access in that regard. We also have this promote a command that will, take it has this implicit order, and if you say promote production, it will go into staging and figure out what actually runs in staging and sort of move that into production. You can check out the project. It's at Lunar Way Release Manager on GitHub. But you might be wondering, what about 4 eyes principle, and how do we actually review changes going into production? Because that's also a requirement from the auditors as well. How can we actually ensure that? And what we did is that in the release manager, we have this global branch restriction rule, as we call it. And it means that only main branches or master branches can be released to production. And we then enforce review on all main branches, PRs. So you cannot get anything into the main branches without having a review from a peer. And there's some additional requirements for each main branch as well. You need to sign your commits. We need to have the status check complete. And this goes for everything, also infrastructure changes to some extent. We are not completely there yet, but I'll come back to that. But what this gives you is, it gives you an audit log. As you see here, this is the Git log of what is happening in the different environments. This is pretty awesome from an audit perspective. And we want to extend this to more than just Kubernetes native resources with custom resource definitions in Kubernetes. You probably heard of this. But from us, for our side, it's more the next level thing about GitOps is putting S3 buckets, all the AWS resources into Git as well, and have the same flow, the same audit, the same sort of disaster recovery as well. Same for clusters and also other types of resources. We created a project called PostgreSQL controller for creating users and databases and manage those in, And the example is, if you need access to a database using the PostgreSQL controller, you provide a custom resource with a name and a reason and stuff like that. And a peer will review this, and once it gets out into the cluster, the controller will pick that up and create the user and provide all the right access to the developer in that sense. So that's really awesome as well. So of course, when you move down this path, you need to follow and secure your config repo and follow the best practices, use MFA, you need to provide branch protection and all that. And I'm running out of time, so just coming back to the requirements, auditability, minimize access, and availability was very important. I've talked about auditability and minimizing access, but availability is, when we have everything in Git, it's really easy for us to recreate a cluster and just apply the source of truth from that Git repository, and that is really powerful as well. So did we succeed? I think we did. This is just a screenshot of our production daily releases. If you see the darkest blue in the right, it's the last 14 days, an average, including weekends. We releasing around 25 releases a day in production. That's quite a lot, I think, compared to many other banks, at least. But are we there yet? There's still stuff to do. We still need to figure out how to do this for all the resources in AWS, our clusters and similar. And just wrapping up, you need to provide sane and secure defaults. You need to make it easy to do the right thing. You need to build security in. You need to provide actionable alerts when you shift security left. And remember that Kubernetes is not secure by default. You need to secure it. That's your task. And also, Kubernetes is not a destination. It's just part of the journey that you are on. There's a lot more to do than just Kubernetes. And embrace change, because change is inevitable. Also for banks. So things change and banks should too. So that was my talk. So if you have any questions, reach out to me on Twitter or send me an email. Thanks.